This was quite controversial. Before you had a mechanism, the idea that birds could sense magnetic fields and use them to navigate when they're migrating. I mean, there was a lot of physicists saying that's just impossible, physically impossible. So why were they saying that?
Because the field is, the energy is very weak. It is so weak that there is no way that it could trigger a biochemical reaction. Like light can trigger a biochemical reaction. Photon as a package of energy is very, very low energy in a magnetic field. So it wouldn't cause any thermal reaction. It wouldn't cause any vibration. It wouldn't cause a chemical reaction. What could it do? It's like saying, since I can't imagine how it could work, therefore it doesn't work.
So the Earth's magnetic field that the birds are
the static
using.
magnetic field, the Earth's magnetic field. Just to put it in perspective, a fridge magnet is 50 times stronger than an Earth's magnetic field. I mean, it is vanishing.
Wow. So you've got the amount of energy so small that the physicists literally can't imagine how it could possibly affect biological cells.
Of little faith,
So how is this happening? How are the birds able to translate such a tiny, weak signal that by rights shouldn't have any effect into responses?
Here I have to resuscitate some very famous and brilliant physicists, theoretical physicists. These are the ones who could imagine. So the first was Klaus Schulten in the 70s, and then his student, which was Thorsten Ritz, with whom I've actually had the privilege of working also. And they came up with a theory how this could actually work. So, magnetic fields cannot affect chemical reactions as such, but they can affect the spin of unpaired electrons. So that's the key.
So this is a quantum characteristic?
This is a quantum physical explanation. Now, where this becomes important is that even a very weak magnetic field can affect an electron spin because, that's a very low energy event. But depending on the electron spin in a chemical reaction, you can get either a lot or a little bit of product. So how it works is that you have a chemical reaction, in this case induced by light, it could be something else, where you have, for example, a receptor, light goes into the receptor, and you produce an intermediate reaction state. This is a very unbalanced, high-energy state, and that state creates unpaired electrons. So it's a transient. It doesn't last very long, lasts a couple of microseconds. But during that state, if a magnetic field comes in and goes poke to the electron, it can change the spin. And if it does that, it doesn't need much energy, it can hugely affect the reaction products of that reaction. So if the magnetic field is not there, you might get 80% product. If the magnetic field is there, it's altering the spin. Then instead of going to the product, the reaction will go back and be unproductive. Another analogy which is beautiful is the idea of how can a fly knock over a brick? The mass difference is huge, but the way to do it is you take a brick, you balance it on its edge, and then a little, it's in a very unbalanced state. A little fly comes flying and gives it a little poke with its antenna, and that brick will fall on one side or the other. So this was the imagined way that a little bit of energy could do a huge change in a chemical outcome.
With the birds, you mentioned that this is acting through the response to light and that the cryptochrome is in the eyes. So how would that work? Would they see things differently depending on which direction they're looking in?
In order to see direction, your receptor has to be oriented. You cannot have a receptor, for example, like in humans, it's the cries tumbling around in solution. It's never going to be able to detect the direction because one cry is never facing in the same. So what the bird has in the eye, they have structured membrane discs where the cryptochromes are actually oriented in arrays on these discs. And that's the closest we've ever come to seeing an oriented system. So all the cryptochromes presumably are stacked and looking in the same direction. So that when the bird turns its head, so this is what you need. When the bird turns its head, it will see the light, the blue light will be the same, but the magnetic field will be different. So it will see that as a different intensity of light. For the bird, it's like it turns its head, the light, whatever that neuron is giving it, will look less or more bright. They think that it's over the whole retina, these arrays are stacked. And that when it turns its head, it sees it as a spot which gets dimmer and brighter. And they know, and they can orient based on that.
It's such a beautiful example of life finding a way to do things, to use information,
I mean,
regardless of whether we can imagine how to do it.
Nobody can imagine this, yeah.